Hello everyone and welcome to this super entertaining crash course on IGCSE Admaths Logarithms. Now I know, Admaths can be tough, logarithms can be tough, and most of you while preparing, you're probably like this girl over here, stressed out from studying so many subjects, so many chapters, each chapter has so many sub-chapters, and you're probably lost in your own world so many times. So that's why I'm here. I'm going to be taking IGCSE Admaths Logarithms, and I'm going to be summarizing every single thing you need to know, every single concept, every single detail into one video. We are also going to be doing practice questions as well as discuss some common misconceptions which some students do. So without further ado, let's get started. Grab a pen and paper and let's rock. Short disclaimer before we start. This is just part 1 of the video, and part 2 of the video will be out very soon on the channel, so stick around for that. The reason behind that is logarithms is a huge chapter, so I was not able to summarize it into one 45-minute video, which is why I have decided to split it into 2 parts. Second thing, if you really like these videos, be sure to like it and share it with your friends, and also tell us on Instagram and our WhatsApp contact if you're actually liking it, because this takes a lot of effort from our side to bring it to you. So if you're liking it, it would be great for us, as we would be motivated to bring more of these videos in the future. And if you're not liking it, it would be a message for us that we should not focus on providing value to you in this way, and we should try other ways to help you out. Okay, thank you, and let's watch the video. So, what are logarithms? Let's start off slowly, build the basics, and as we go, we'll pick up pace and go a bit more advanced. Okay? So what I'm going to do is I'm going to take a general equation. Let's call it a power b is equal to c. Okay, 3 variables. So now I'll take 3 situations. In each one of them, one variable is unknown. We have to find the variable. Okay, because we'll know other 2 variables. Okay, the first situation, this is very simple. Okay, this is just your 7th grade maths. Okay, you will wish that you get these type of questions because it's so easy. 3 square is equal to c. So I know a, I know b, I have to find c. Okay, great. C is just equals to 9. Wonderful. Let's take a second situation. In this, it's something like x cubed, suppose, is equal to 27. So now I know b and c. I have to find a. So sure, okay, it's just cube roots. X is equal to the cube root of 27, which comes out to be 3. Okay, great. Nothing new here. Now, let's go to a third situation. Let me do this in blue. Okay, let's make this third situation in which b is unknown. So, how will that look? 3 to the power x is equal to 27, let's say. Okay. Now, we know that 27 is just equal to 3 cube, right? So 3 cube. And since we are very good with our knowledge in exponents, we know that, oh, this 3, die. So what is left? X is equal to 3. Yes or no? Okay, x equals 3 because 3 to the power 3 is equal to 27. Okay, again, just basic stuff. Now let's take a different color for the fourth scenario. Huh? Till now you told me 3 scenarios, now you're putting a fourth scenario. The fourth scenario is like an extension of the third scenario, okay? No need to worry much. Okay, the fourth scenario is something like 3 to the power x is equal to 70. Now, it's a little bit interesting, okay? Because we can't really know a value for x here. Like sure, we know that 3 to the power 3 is equal to 27. We know that 3 to the power 4 is equal to 81. 70 lies like in the middle of the two. And it lies more towards 81. So you will know that it's something like 3.5, 3.6, but you don't know exact value, right? So that's where logarithms comes in. Okay? Because in something like situation number 3, this is very obvious. 27 is 3 cube, everyone knows this. But 70, okay, we don't know what value we can get. That's where logarithm comes in. And let's take the essence of it. Let's not try to solve this equation first. Okay, so what works is, like how we write logarithms is something like log base 3 70. Now what does this mean? I'll explain. Okay, I'm not solving any equation right now. Okay, but if you already know logarithms, you will know this is equal to x. But I'm not solving an equation right now. I'm just trying to explain the concept. Okay, so I won't write that yet. Okay, so you can see there's this log written there. Then at the bottom there's a 3, and then you go back up the top, there's a 70. So now what's going on? Okay, what these numbers are basically some special names they have. This 3 is called the base. I mean, you could think of it as below log, so it's like the base of something, it's below something. And the 70 is the argument. Okay, sure, you can think of them that they are fighting, their argument. Okay, sure. But what does it tell you in terms of maths? Okay, because we can't just say, oh, this is the base of a building and those numbers are arguing. Okay, you can't say that. So what does it mean in terms of maths? What it basically tells us is 3, I'll write it here, 3 to the power something, or 3 to the power what gives us 70 in this case. So we know that 3 to the power something gives us 70, right? But we don't know the exact value of that something. That's what we're trying to find. This log base 370 gives us that something, or it gives us that what. Okay, I think what could be a better word. So it gives us that what. And in this case, 3 to the power x equals to 70. X is that what, right? That what is just x. So x is equal to log base 370. Now we can just put that in our calculator. Okay. So I will get x is equal to log base 370. Let me solve that. So to 3 significant figures, it will be approximately 3.87. Now what that means is that 3 to the power 3.87 should approximately give you 70. Now, I know some of you will be very curious. You will put this in your calculator. You will be like 3 to the power 3.87. It will give you 70.2. Now, why is there 0.2 extra? My dude, this is because this 3.87 over here is an approximate. Okay? If you use the exact value of this, then you will get 70 here. Using 3.87 is giving you 70.2, but that's okay, right? Because you are approximating this value. Okay, so this is what logarithm actually means. So this was in terms of an example. Let's consider logarithms a bit more generically. Okay, so let me go back to my general equation. Let me use black now. Okay, a to the power b is equal to c. So let's revise. If we write log base a argument c, it means a to the power what gives us c, and a to the power what gives us a b, right? So this is literally how you just convert it from this first line to this second line. The logic behind it is we want to find b. We want to make b the subject. You can think about it, because many times it's so easy to find a and c, but to find b, like 3 to the power something equals 70, finding that something is not very intuitive many times. Okay, by intuitive I mean you can't know the exact value. Like you won't just have a dream that, oh, 3 to the power 3.87 gives you 70. Okay, that's why this mathematically calculates it. It makes b the subject, and what it essentially means is a to the power what. This is the what, the b is the what. So a to the power what gives us c. Okay, so now let's go a bit fancy terms. Okay, let's pick back green. In fancy terms, they call this the exponential equation. Okay, you don't need to know this, but it's easier to understand it this way. And this is called logarithmic form. I mean, it makes sense, right? Here b is to the power, so it's an exponent, and here the b, you're using a log here, so it becomes logarithmic. So essentially what we have just done is in lingo just converted from exponential to logarithmic form. And in terms of words, it looks like we have climbed Mount Everest, but in reality, we've just done one step, and that step is so simple. Like a to the power something gives us c, right? So we just done log base a c, and what it gives us is that something, that what in this case. So this is a general form. Of course, with numerical values, it can look something like the one I've done in blue and green. Log base 370 is equal to x. So that's the basics of logarithms. So to understand, to get this, to a better idea, because we've just tried one example, let's try a bit of more examples, okay? Because to many of you, this might be a new concept. So let's try some more examples, okay? Now, let's look at some common base for logarithms. What does common base mean? Huh? No, don't worry. Like, that time I told you a power b is equal to c. So b is equal to log base a argument c. So there are some common values of a actually. Common values of a. For example, let's take 10. Why am I not able to write? Okay, sorry about that. For example, let's take 10. Okay, 10. 10 is a very common base. So general equations could be like 10 to the power x is equal to 99. So then x is equal to log base 10 argument 99. Here 10 is the base. Okay, 10 is a very common base, and if you're wondering why it's common, where it's used, it's actually used a lot in chemistry. And you'll be like, chemistry? How's chemistry using maths? Well, I won't get too much into that, but if you are aware of the concept of pH, which is used to measure the acidity or the basic or how alkaline something is, pH actually uses a lot of logarithms, and pH calculations involve logarithms. And 10 is the base there. So 10 is a very common base. Another very common base is E. And E is just a constant, like how you have constant, pi's value is approximately 3.14. We have E, whose value is approximately 2.718. Now you'll be like, how is E important? We know pi is important in circles. Someone just said E is important and we just agreed. No, there's actually a very important reason what makes E so important and what makes it a common base for logarithms. But we won't get too much into that right now. As you learn admaths further, there will be this chapter which you learn called differentiation. Now you will learn the significance of E. Just how in circles you know the significance of pi, you will also learn the significance of E. Okay, but I won't get much into that right now. So let's take an example. Suppose e to the power x is equal to 3. X would then just be log base e argument 3. So e is the base here. E is also a very common base. Now let's just get used to some notation. Okay, 10 and e are very common bases, that there are some specialist symbols which can be used to represent them. For example, log base e is so common, instead of writing log base e every time, what you could do is you could just write ln. Okay, so ln is equivalent to log base e. It's just a short form. You know, it's saving you 2 letters. Okay, so I guess it makes a lot of difference for mathematicians. That's why they use it. And for log base 10, they write lg. That's equivalent to log base 10. So then this equation could actually be written as x equals to lg 99, and this equation could be written as x is equal to ln 3. Okay, and this ln, log base e, has a special name. It's called the natural logarithm. More on that later in the video, but this is just overview. It's called the natural logarithm. Now, how is it natural? Is it like very natural in our everyday lives? Again, that has a relation with what we are going to do in differentiation, and I don't want to spoil too much right now. If you want, you can do your own research. Okay, so this is some things for common bases. One is base 10. Okay, it can be written as lg. One is base e. E is a constant, 2.718. It can be written as ln. Or saying ln or the natural logarithm could be hard or long sometimes. So many people just say ln, including me. So I'm going to be using ln from now. Yeah, it's basically ln, like it's easier to say. So I'm going to be using ln to denote ln or the natural logarithm from now. Okay, let's move on. Okay, now that we know a little bit about bases, let's try to know a little bit more. Okay, because bases are slightly more detailed than just knowing about the common bases and converting from logarithmic form to exponential form. Okay, there's a little bit more detail you need to know. Okay, what's that detail? Let's explore. So suppose your y is equal to a power x. Now I'm not using ABC anymore because I'm going a bit more professional. Like this is how it's generally written, because y and x are our favorite variables. So then x is equal to log base A, y. Nothing new over here, okay? But there are certain logarithmic rules or logarithmic principles, okay? Now, if you're my student, you will know that there's no such thing as a rule, okay? There's no such thing as a rule because everything can be proven. Rule is almost like, here's the thing, I don't know why it happens, or everyone has different definitions. But the point is, it can be proven. It does not need to be memorized, okay? Let's look at the first rule, okay? That rule is that if you have log base A, argument A, is equal to a number which I want us to discuss instead of me just explicitly telling you, okay? So what does log mean again? A to the power what gives you the argument. The base to the power what gives you the argument. So A to the power what gives you A? Just 1, right? A power 1 is equal to A, right? So log base A, argument A is just equal to 1. Right? That's simple. A to the power what gives you A? A to the power what gives you A? A power 1 gives you A. Isn't it? Okay? Okay, so let's go to our second rule. Okay? And that rule is that if you have log, okay, I have to write it. If you have log base of A and the argument is A to the power x, it gives us a number which again, let's discuss, okay? Recall the definition. A to the power what gives you A power x? I mean, the question just tells you A to the power what gives you A power x? A power what gives you A power x? A power x gives you A power x, right? A power x is equal to A power x. It's like saying 1 is equal to 1. Right? So A to the power what gives you A power x? Just x, man. A power what gives you A power x? Just x. Isn't it? Simple. Okay? Let's move on to rule number 3. Okay? And let me do this in a different color. The third rule is that you have log base A, and if the argument is 1, it gives us another number which we should discuss right now. Again, simple stuff now. Recall our definitions. A power what gives us 1? A power what gives us 1? So A power some x gives us 1. Okay? And we should know from our indices and from our concept of powers that something to the power 0 gives us 1. A to the power 0 gives us 1. Now you'll be like, actually, you might be thinking, why does something to the power 0 give us 1? We've learned it for so long, why does something to the power 0 give us 1? If you're my student, you probably know this. And if you're not, if you're interested, I could make a video on this. Just tell me in the comment section. But right now, that's a bit irrelevant to our revision. But if you're interested in it, just let me know, okay? But we know A power 0 gives us 1. So A power, so log base A1 is A power what gives us 1? So just A power 0 gives us 1, right? So this is equal to 0. Again, simple stuff, okay? Simple stuff, no need to be too confused. And if you're confused, just rewind the video, you should understand, okay? Let's go to our fourth rule. You're getting the idea by now that hopefully it's not really a rule, it's just logic. Okay? And that rule is that if you have A to the power log base A x, it gives us a certain something which let's explore. Okay? First, let's take the power. Let's study the power. Power is log ax. Okay? So I'm studying the power first because the index and the log might confuse you together. So what is log base ax? A to the power what? Okay, so now we're already using x. So let me use something like y, a power y gives us x, right? So this log base ax essentially just gives us value of y, right? Doesn't it just give us the value of y? Because log base ax is essentially just y. I'm assuming y is the power now because they've already used x as the argument. So if log base ax is just equal to y, and you have basically then a to the power y, and a to the power y is just equal to x, then this should just equal to x, isn't it? Simple, right? If you have a to the power log base ax, if you're too lazy to do this working, let me just explain to you in words. So a to the power what gives you a? A to the power what gives you a? Oh, sorry, x. Sorry. A to the power what gives you x? So you're getting the power. So a to the power y should just be x. Okay? A to the power what gives you x? So a to the power y gives you x. Okay, we are assuming it's y. So a power y is equal to x. So a to the power log base ax is just equal to x. If what I said orally was just too complicated, you could just get an essence of it from here, or you could just repeat the video and try getting a better understanding until it's glued to your head in a way that you understand it conceptually and in a way that you also don't have to prove it in the exams many times. Because you don't want to prove these rules in the exam, you should have them by heart, but you should also know where it comes from, right? So do make sure you have them by heart, but get a sense of it. Like, it should make almost common sense to you after some point, okay? So let's move on. Hey guys, I hope you're enjoying the video. Just a very short message from my side. Please don't skip, please don't fast forward. I promise it's a very, very short message and it could practically just change your AdMaths life, and I mean it. And what I want to say is that Shamo Classes is offering IGCSE tuitions for AdMaths. Now I know what you'll be thinking. Of course, Shaved, you have to talk about your own tuitions in your own video of the Shamo Classes, right? Well, here's the thing, okay? What we're doing here in these one-shot series, they're great, okay? They're great. Their effect is phenomenal. That's why we're doing it. But the only limitation is that they're just a summary of the whole chapter. They don't go in depth. They're just a summary of the whole chapter, which briefly covers everything. It doesn't really go as much in depth as you would like to as a learner, right? And it doesn't give you an essence, a visualization, or a feel of the chapter. It's just a summary. So in these classes, what we aim to provide is giving you that essence, that feel, that, understanding and visualization of the chapter, which can't be given in 45 minutes. So this will really boost your understanding. Boosting understanding means boosting grades. Okay? So if you're interested to join, why won't you be interested actually? Who doesn't want better understanding and better grades, right? So link is in the description, details, everything in the description and in my camera as a side. I don't see a reason you should not join. Now I know what you'll be thinking. Shamit, you're not even qualified to teach. YouTube videos is fine, but tuitions? Actually charging money for something? You need a degree for that. Well, do you? What do you need to teach? Knowledge and explanation, right? Okay, number one, knowledge. I got a pretty good grade in my IGCSE. I got an A star. You all also got an A star. I got an A star. So knowledge should not be a problem. Okay? You're learning from someone who got an A star. Right now you're watching this video. Is knowledge a problem for you? No, right? Right now you're watching this video. Is my way of explanation a problem for you? No, right? And if you're still not convinced, These testimonials speak for themselves. Now enough of me talking. Let's get back to the video, okay? This chapter is important. Now guys, it's important to understand that there are some constraints or restrictions to the value a particular base or the argument can take. So let's try understanding them, okay? So one of them is that the base can never be equals to 1. Now why is that? Okay, let's try figuring it out, okay? Suppose you have something like log base 1, 3. The argument's 3. What does this mean? 1 to the power what gives us 3? 1 power x gives us 3. Now what? Like Nani? 1 power x equals to 3? That's not possible, right? Because 1 power anything can always be 1. So 1 power x is equal to 3 is just not possible. So next time someone tells you, hey, you know the base can be 1. You know what to do? Just slap their face, okay? Because a cannot be 1. Because 1 to the power something is always 1. So 1 to the power x just can't be equal to 3. So this is one restriction, that a can never be equals to 1. Okay? There's another one. Like 2 more. Okay? And both of them actually go hand in hand. And that is that a must be greater than 0 and x must be greater than 0. So the base must be positive and the argument must be positive. Now why is that? Okay? Let's try figuring out. Let's take the help of an example, okay? Suppose you have log base of -2 and argument of -4. Essentially what you're doing is you're asking -2 to the power what? So -2 to the power what gives you -4? Now ask yourself this, is this really possible? -2 to the power x equals to -4. Can we solve this? Is it possible? Think of one value of x which might give you -4. Yes, -2 to the power 2 can give us +4 if the whole thing is squared. But -2 to the power x can't give us -4. Okay? If any of you finds any real value of x, real value means any number or fraction or anything which gives us -4, you tell me. And if that happens, I'll do a dare which you guys tell me to do. Okay? Because I'm sure it won't happen. -2 to the power x is equal to -4. There are no real solutions for it. Okay? Sure. Now you might be thinking, okay, got you. But -2 square can give us +4. So why can't log base -2 4 exist? Right? No, that's a good question. Well, the reason you could think of is that there are so many uncertainties. Like this is just one specific value where it can exist. You know, but like log base -2 4, sure, okay. Yeah, you could say that -2 square is equal to 4, so this should technically be equal to 2. But these are only just a few ways where this actually works. Because I could give you countless examples. Okay, let me just close my eyes and think of a random example. Log base 3 of -9. 3 power x equals to -9. It's not possible. Because whatever value of x, 3 power x will always be positive. Or let's take an example of a negative base. Log base -3 of 15. Okay, -3 power x equals to 15. No. You can't. Okay? Only some values you might argue, yes, it's possible. But majority of them, it's just not going to happen. So to avoid that confusion, I would say that I guess I've defined it in such a way that the base is always positive and the argument is always positive, and of course a is not equal to 1, the base is not equal to 1 based on what I said earlier. 1 to the power anything is just 1. So these are some important restrictions to the values which you should know. Now why are they important to know? Well, that is because sometimes while solving you might have to solve for x, and suppose you get two answers. Suppose you get x equals to 2 and x equals to negative 3. Now some students will underline both, saying, yeah, I got 2 answers. But what will happen is negative 3 is actually not an answer because the argument has to be positive, so they will lose 1 mark. Not negative marking, they just won't get 1 mark. Unless they say that only 2 is the answer and 3 is rejected. Okay? The reason why this is important because sometimes you might get multiple values of x, but you must know if we can accept all of them. Okay? I hope that made sense. Let's move on. Okay, now let's move on to a very important subchapter, and that's logarithmic laws. Okay? Now, explaining these and proving these, it'll take a long time. Okay, this is just a summary video. And now that we've grasped all the basics, I'm aiming to speed things up to save everyone's time. So these are the laws in purple over here. That log base a xy is equal to blah 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 and blah blah blah. Okay. Yes, I like proving things, which is why I've attached the proofs for you. But if I have to write those proofs manually and explain it one by one, it's going to be taking a lot of time. And these proofs are honestly not very complicated proofs to understand, which is why I just attached these proofs. In fact, it's actually from one of the AdMath textbooks, which I use as a student. So here are 4 laws, and the proofs of all of them are given. Okay, so it's important that you memorize these rules, and knowing the proofs, of course, it's not in your syllabus, but it's great to know where it comes from. But whatever is highlighted in purple, make sure that you practice enough that you know it. Okay, and it sort of is easy to remember, Think of it this way. Log base a xy, okay? So think of multiplication as good and addition as good. So whenever 2 things are multiplied, their bases, they are like the logarithms add, and whenever the argument is divided, the logarithms subtract. And this one I have to say a bit. Let's be careful, okay? This one, if it's log base a x to the power m, then only it's m log base a x. Only if x has the power m. Suppose it's log base a x, the whole thing to the power m, some students will be like, oh yes, I know there's power log. So m log base a x. Hello? Nope, this will not work. It will only work if x has the power, not the whole thing. Okay, x must have the power. This is wrong. Okay, many students can get that confusion, and that might result in you losing a bit of marks. Okay, so just be careful with that and memorize these 4 laws by heart, which shouldn't be that difficult because of some shortcuts I told you, and generally they aren't that hard to remember. Okay? Okay, now let's move to solving logarithmic equations. Now many of you will get scared. You'll be like, huh? I already solved logarithmic equations, right? 3 power x equals to 5, x equals to log base 3, 5. I don't want to solve more than this. Sorry dude, you have to. Life sucks. Okay? So a typical logarithmic equation will look something like this. Okay? And I think it covers most parts of what you need to know about logarithmic equations. So that's why I've chosen this example. Okay? Let's try approaching this. I see base 5 here. I see base 5 here. I see they are being added. Does it spark a bulb? Technically, it should spark a bulb that, okay, they have the same base, they are multiplied, so they are added, so the arguments multiply. Okay, so it will become something like log base 5. Now I open a bracket for the argument, so x plus 8 multiplied with x plus 2. Now this is just the addition law. We did the basic logarithmic laws. So this is equal to log base 5, 20x. Cool. Now, 9 standard multiplication, x plus 8 times x plus 2, very simple. It's just x square plus 10x plus 16 is equal to log base 5, 20x. Now, a lot of your guys' favorite. Okay, you'll be like, oh, log base 5 on the left hand side, log base 5 on the right hand side, kill, kill. So you'll be thinking, oh, we can just cancel bases like that. And you're not wrong. You can do that. But for those of you who are curious why we can do that, let me explain it to you. Okay? Many of you will be like, oh, you know, if it's exponents, we can cancel, so why not with logarithms? Equality principle. Well, not always, okay? There has to be some logical reasoning behind it. And here's what I can give you. Suppose you have 3 power x equals to 5, our favorite example. X is equal to, okay, there's a little bit of lag, I'm sorry. X is equal to log base 3, argument 5. Right? This is just simple stuff which we have done. What I'm going to do is, I'm now converting. We've always converted from exponential to logarithmic, right? Let me convert from logarithmic to exponential. So basically what happens is this 3 in the base jumps to the bottom of the exponent. Alright, this 3 over here is the base. Okay? And this x over here is the exponent. So it becomes 3 power x equals to 5. So if we have x equals to log base 3 5, essentially what happens is that this 3, okay, it has divorced with the 5, it marries to the x, so the 5 is all alone, so it becomes 3 to the power x equals to 5. Okay, the 3 and the 5 broke up, the 3 hooked up with the x, so it becomes 3 to the power x equals to 5. That's just, essentially I'm doing the opposite, okay. So, in this case, when I have log on both sides, it's slightly tricky, but not very deep either, okay? Essentially what I just have to do is, okay, this 5 hooks up with this one, this 5 hooks up with this one, okay? So 5 to the power log base 5, 20x is equal to 5 to the power log base 5, x squared plus 10x plus 16. And sure, I should put a bracket for the argument, right? If not, I'll be arrested. Okay? So sure, I'll do that. Now these two can cancel. Now these two can cancel. You know why? If you don't know why, then take a pen or paper you're writing and hit yourself like this. Okay? My dude, then if we do this, 5 to the power log base 5 of something, then they can just cancel. We did this when we were doing some basic logarithmic laws and some properties of logarithms, isn't it? It's 5 to the power what? So they just cancel. Right? So now that they cancel, you can see, yeah, eventually we've just gotten 20x is equal to x squared plus 10x plus 16, which is kind of like the same way as saying that sure, these two log bases 5 kill each other. Yeah. Okay, sure. I was just trying to explain it intuitively. Okay, for those who are curious. So then I'll just solve this quadratic equation for x. So x squared minus 10x plus 16 is equal to 0. Okay, let's get some space. We have x minus 8, x minus 2. This is just 9 standard factorization, right? None of you should get this wrong. Is equal to 0. Now x equals to 8, x equals to 2. Very simple, right? Now there's a small catch. What's the catch? Here's the catch. Can we accept both answers? X equals to 8, x equals to 2, both are positives, right? So technically we should be able to accept, right? Because x has to be positive. No, x does not have to be positive. Now you'll be like, huh, just now you told me x has to be positive. You're contradicting my statement. Now I don't trust you. No, I never said x has to be positive. The argument has to be positive. This thing, x squared plus 10x plus 16 and 20x. These two have to be positive. So now you'll be like, huh? Okay, yeah. X square plus 10x plus 16 has to be positive. So do I do this quadratic inequality thing? That okay, I do x square plus 10x plus 16 has to be positive. I do that weird graph thing. Okay, then I get 2, then I get 8, then I go here, then here, and then I see if I can reject or not. That's so much work. Do I do that? Well, you don't need to, okay? Most of the time, through common sense, you should be able to tell, okay? Well, you don't need to do that. Most of the time, through common sense, you should be able to tell, okay? Ooh, from common sense, we can tell that. How? Okay, simple. X square plus 10x plus 16 has to be positive, right? So, I mean, if you think about it, if x is positive, there is no way in hell that if x is positive, this comes negative, right? Positive number squared plus 10 times a positive number plus 16. So this just has to be positive no matter what happens, right? Oh, and by the way, I'm sorry, I just realized this will be my... Yeah, sorry, nothing. Everything's fine. So x square plus 10x plus 16, it will be positive for 2, it will be positive for 8. And 20x, it will be positive for 2 and positive for 8. So yes, in this case, correctly, we can accept both answers. Yes. Okay, so x equals to 8 and x equals to 2. In the case where we cannot accept both answers, okay, because sometimes what will happen is you might get a value for x for which the arguments are negative. You might get a value for x for which the arguments are negative. Let me give you an example. Let's say you got x equals to negative 1. If we got x equals to negative 1, then what we have to do is reject it. You know why? Because here 20 times negative 1 is negative 20. Negative 20 is negative. Argument can never be negative. Okay? So in that case, we will have to reject it. So what we have to do is we have to be careful on when to reject and when to accept answers. Okay? So it was just simple. You know, we use the multiplication law at the start. Then we just kill logarithms. You know, by killing logarithms, you know, it was log base 5 on both sides. So just here. And then it was a normal quadratic equation. But we just have to be a bit careful if we can accept both the answers or not. Okay, let's move on to the next subchapter. Okay, solving exponential equations. Here I have a question for you, and I've chosen a hard question because this is revision, and a hard question explains many concepts together. Okay, so get your pen and paper out. I challenge you to solve this. Here it goes: 25 to the power x plus 20 is equal to 12 times 5 power x. Ooh, okay. Pause the video. I'll wait 2 seconds and then we can solve this. Okay, this is a relatively hard question. Standard, you could say. You can expect these type of questions. And it explains quite a few things in solving exponential equations. Now, it would have been way easier if instead of 25 power x, it was written 5 power x. But they had to make our life difficult. They just gave it 25 power x. Some people will be saying, oh, okay, so 25 power x is just the same as 24 power x plus 1 power x. No. No. Please revise your concepts again. Let's take an example. 25 square is not the same as 24 square plus 1 square. Okay, 25 square is, I believe, 625. Let me just confirm. Yeah, 625. And 24 square is 576 plus 1. No, they're not the same. Okay, so don't do some cheap tricks. Okay, so we can't do that. So somehow we have to manipulate the equation in such a way that we have the same variable. Okay, how can we do that? Let's explore a little bit. Okay, and this is an important concept you need to know. 25 is equal to 5 square. We know that. That's not the important concept, okay? Don't be very happy that, oh, I know the important concept, 25 is equal to 5 square. No, 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 no. Okay? So 25 power x is the same as 5 square to the power x. Do you agree with this? I'm just writing 25 as 5 square. Nothing is different. And you know that this x can be multiplied with the 2, right? It can become 5 to the 2x. Or I could just do 5 to the x square. I switch the positions. Is anything changing? Dude, this x, if it multiplies here, it becomes 5 to the 2x. Here also you're getting 5 to the 2x. It's the same thing, right? 5 to the 5 square power x can be written as 5 power x square. Okay? If you're not sure about what just happened, just look through my explanation again or revise your indices, okay? Because maybe your indices is a little bit weak and you might need some brushing of that. Okay? So, cool, okay? What's the end point? That means, let me just erase this. So we know that 25 power x here can be written as 5 power x square. Now you'll be like, how does it help us? It actually does, because we have 5 power x here. Okay? And if you are my student, you will be aware of this. And if you are not, then you still have a chance. All my details are given. Okay? So the idea is, let's make a quadratic equation of this. Now you'll be like, this is exponential. How do we make a quadratic equation? Okay? Here's the idea. Let, and I'm going to use the letter S, okay? S, why S? Because my name is Shamo, so I just like S, is equal to 5 power x. Now what we are doing is, okay, let me rewrite this equation. 25 power x is just the same as 5 power x square. So let's use blue. 5 power x square plus 20 is equal to 12 times 5 power x. Now, if I'm saying s is equal to 5 power x, I could just replace all the 5 power x with s, right? So this becomes s square plus 20 is equal to 12s. This is the quadratic equation I was talking about. So then, just solve this, easy peasy. S square minus 12s plus 20 is equal to 0. I hope you know how to solve a quadratic equation, right? Should be simple stuff. So let me think, what are the roots? I think 10 and 2 should do it. S minus 2, S minus 10 equals to 0. So you get S is equal to 2 and S is equal to 10. Some students will be very happy and be like, hey, this is my answer. S equals 2, S is equal to 10. Give me my marks. Well, here's the thing. There's nothing wrong in your factorization. There's nothing wrong in your method, but you won't get full marks. Why? Is there some conspiracy? No. Okay? This 2 and 10, they are the values for S, my friend. They are the values for S. You want the values for X. You know, the equation is in terms of X. You want the values for X, not S. So you'll be like, oh no, okay, we have for S. How can we find for X? Remember, we defined here S is equal to 5 power X. So if S is 2 and S is 10, it means 2 is equal to 5 power X and 10 is equal to 5 power X. Isn't it? So now we could do simple logarithms. X is equal to log base 5 2 and X is equal to log base 10 5. Now if you agree with what I just said, slap yourself. Okay, slap yourself. Why? It's not log base 5 2, it's log base 2 5. Okay, if you did not notice this, just slap yourself. It's a joke, huh? Please don't slap yourself. No self-harm. I was just being a bit I was joking a bit, okay? So it's log base 5 2 and log base 5 10. And then you could use a calculator to solve it, and it will give you the answer in 3 significant, and like you could give your answer in 3 significant figures. So log base 5 2 in the calculator comes to be 0.431. And log base 510 comes to be 1.43 approximately. So if you use these values, you can see argument is both positive, we can accept both answers. If we use these values and we go up, 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 and we substitute these values here, we'll get the left hand side and the right hand side to be same. Now you'll be like, suppose you actually try it and you don't get them as the same. The reason behind that would be because x is an approximate. Okay? If you are savvy with your calculator, you could just use answer instead of x. You know, you could store your answer in answer like that. Calculators have the answer button there, right, which stores the latest value. So you could just substitute answer there, which will give you the exact values. But be sure not to mess it up, because the answer will change when you put the left hand side. So suppose left hand side you get a value, right hand side you won't get the same value with the same answer. Okay, if that went over your head, it's okay. What I meant to say was that these x values are correct. Try putting them back in the equation, it will satisfy the equation. That was my point. Okay, so this is a very important concept, that we manipulate the equation in such a way we get a quadratic equation. Okay, and by the way, I just use s. Okay, you could use p, a, b, c depending. Okay, I would just go with whatever your name starts with. I just like that. Okay, L, A, S, P, Q, R, anything. Okay, so that was one question of solving logarithmic equations and exponential equations. Let's move on to change of base. There's one place many people get stuck. Okay, now let's move on to this concept of change of base of logarithms. Now what happens actually is that suppose I want to find log base to 5. Okay, but for example some calculators, they only have log base 10 as an option. So how can they solve log base to 5 using log base 10? And that's not the only application. Yes, some people will be like, oh, not my fault, you know, get a better calculator. No, that's not the only application of it. Where other applications will be to simplify some equations, which, you know, it's better to have the same base so you could solve the equations with ease. And another application is, it's in our syllabus. You know, we want to learn it, we want to get a good score. And of course, it has other applications also apart from just your grades, you know. The most probable one which I can think of on top of my head is to simplify some equations so that you have the same base. And if you have the same base, you know, you could do your log cancel thingy. Remember your log cancel thingy? If not, rewind the video. Okay, I explained it. So there's actually a formula for it, and that formula is, I think, the reason many people don't like change of base. Okay, it's given here. Log base b argument a is equal to log base c argument a over log base c argument b. Let me write it down so that you can digest it, because I might have said it too fast. Is equal to log base c argument a over log base c argument b. Again, if I take the proof of this, it will take a bit of time, and since this is just a revision, I am aiming to make the video as conceptual but also short at the same time. Okay, logarithms is a huge chapter, it's one of the biggest chapters in your Add Maths, so for the sake of time and for your better revision, you could ignore the proof if you want. If you are very interested, I have also given the proof here. It's again from the same textbook. Now, how to make this formula easier to remember? It sounds so complicated. Log BA is equal to log CA over log CB. Okay. Now, if you know me, I hate memorizing. So I don't know how I do chemistry. Okay. But I just created a very silly but useful way to memorize this formula. Because you can't prove this every time, right? Proofs are cool, but you can't prove this every time. So here's how it goes. I just read it out. Instead of saying log base b argument a, I just go as if I knew nothing. Log bar is equal to log ka, log curve. Okay. Now, as silly as that sounds, It's actually quite easy to remember and quite useful. Okay, if you're finding difficulty in memorizing this formula, that's how that's just how I do it. Log bar is equal to log car log curve. Log bar is equal to log car log curve. Log bar is equal to log car log curve. If you find it silly, well, yes, it's silly, but if it helps you memorize it, I don't see any harm in that. Okay, so log bar is equal to log car log curve is how I remember. And basically what happens is they take the new base and the old argument is in the numerator, and the new base and the old base is the argument of the denominator. Now that's a bit complicated to remember, right? And saying log base b a blah 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 is also hard to remember. So just log bar is equal to log car log curve. Okay? And then there is this formula here. It's not really a formula. You could just get it from here. They say if c is equal to a in the change of base rule. Okay? So no need to memorize this formula. You know, I suggest just memorize this one. So if log base b is equal to log base ca over log base cb, and they are saying that if c is equal to a, so over here c is equal to a, I could do something like this. And log base a is just 1, so 1 over log base cb. Well played. Not bad, right? Just memorize this one formula, and this second formula is just basically just derived from that. And an easy way to remember the first formula is log bar is equal to log car log car. Okay? Okay guys, that's the end of the first part of the video. We will have a second part also. I hope you really enjoyed the first part, and if you did, please let us know. Okay? I hope you had fun. I hope you'll keep having fun in your studies. I'll see you in part 2. Keep having fun. See you. Peace.